In this lecture, we are starting off with a new module, the entity relationship model, ER model. Let us briefly recall what are data models. A data model is essentially a set of conceptual tools that we will use in order to describe the database at a certain level of abstraction. And we need data models because database systems are, the databases that we build are pretty complex, and we would like to describe them at various levels of details. Now, to describe the database at a conceptual level, where we can use that for discussion with the stakeholders and get the requirements clearly, there are couple of models. The most popular model is this ER model, entity relationship model. So, let us begin with this entity relationship model. It was proposed by Peter Chen in the 70s, 1970s, and it is kind of widely used conceptual level data model. In this module, we will restrict ourselves to a basic ER model. There is an extended ER model called EER model, extended entity relationship model. That would be actually required if you want to go into more details about the data modeling, typically required for advanced databases like databases dealing with engineering designs, artifacts, multimedia databases, and such databases might require a more detailed modeling than offered by the basic ER model. The basic ER model is sufficient for most purposes, and especially for capturing the typical databases that we will build while dealing with business applications. Right. Typical enterprises like banks and online stores and things like that. So, we also want to move on to the central data model, which is the relational data model, a little quickly, so that we will keep this ER model, we will restrict our discussion to the basic ER model, and if time permits, we will look at the extended ER model. Okay. Now, so typically this is the model, the data model that we will use to describe the database system at the requirements collection stage. So, it kind of gives a very high level description, and it is easy to understand for the enterprise managers, business enterprises for whom we are constructing this database. This is important because we would not expect all these people who are involved in the management of the enterprise, to be conversant with computer science and know all the details about how database systems are to be built and things like that. It is not required for them, but the database has to be built based on some clear understanding of the requirements, and so we will need a rigorous enough model to describe the system that is being built. Okay. And ER model offers that kind of a facility. So, the concepts available in this model are the concept of entities and attributes of these entities, and the concept of a relationship, which is a association between entities, and we also discuss a detailed diagrammatic way of writing down this model, so that we can share it with the stakeholders, and then we can use that as a means of describing what we have understood about the database, and then get a clear go ahead from the stakeholders. Okay. Okay, so let us begin with entities. What exactly are these entities? An entity is a thing of independent physical or conceptual existence in our domain of interest, and it could be animate or inanimate, but it is a, what is important is it is a independent existence, and it is also distinguishable. Okay, first let us look at some examples of these entities. In a university database context, let us say each individual student, each individual faculty member, a classroom, a course, all of these can be thought of as entities. Now, you can see that the student, faculty member, a classroom, these are real physical things, whereas a course is a conceptual thing, right. Course is a conceptual thing, and they are all distinguishable because they have certain distinguishing characteristics, and we can tell one entity apart from the other entities. For example, if you take a bunch of blue marbles, this distinguishability does not occur. It is very difficult to distinguish between one marble and the other marble. So, such kind of things we cannot treat them as entities. A bunch of eggs, for example, right. All of them look like, whereas here these entities are clearly distinguishable from each other, and they are of independent existence, and this is the and these are, so this concept of entity is basically made use of in this data model to kind of capture as to what are the entities of interest in the domain to be kept track of. Okay. So, for example, in the university database context, it is these entities like students, faculty members, classrooms, courses, all of these things have to be kept track of. Now, the concept of entity set or entity type is also associated with this. Basically, the collection of entities all having the same characteristics or properties, okay, are together called as the entity set or entity type. This is a very familiar idea to us, because we have already been dealing with data types. Data types are nothing but collections of pieces of data, all of the same type, like integer data type, real floating value data type. Right. So, now we introduce entity type. So, all entities of the same kind are grouped together, and we call them as a entity type. So, the student entity set is the collection of all student entities, individual student entities. The course entity set is the collection of all course entities, like that. Okay. So, this is one of the basic concepts provided by the model, the concept of individual entities and the entity type. Now, the concept of attributes is used in order to capture the associated information for an entity. In fact, not only for entities, even for these what are called relationships, there are some associated information, and we will use the concept of an attribute to capture this associated information. So, basically attributes are used to kind of describe the entity in more detail. So, each entity is described by a set of attributes or properties, and in this context we will also assume that the entities of the same of a particular entity type, all of them have the same set of attributes. Okay. Okay. So, we will come to that. So, let us take student entity. So, these are some of the various attributes that we would like to keep track, associated information with the student entity, like student name, name of the student. Roll number is an attribute that assumes values of roll numbers for the student. Sex is the gender of the student, like that. So, these are the various, we will go a little deeper into these attributes in a short while. There are various kinds of attributes, we will see them all. So, all entities in an entity type or set, characterize that entity, Okay. Now, so of course, the reason why you are interested in entity name, like the student name, is that this will capture a value. So, okay. Now, what are those chosen set of attributes? Should I include student blood group also in the same set of attributes? No, that is a matter of design choice. That is a matter of design choice and a matter of how detailed you want to go in the modeling and what is the purpose for which the data is being captured and then used. So, it all depends on that. So, the amount of detail in the modeling is a design choice. Okay. So, some appropriate set of attributes would be chosen to serve the purpose of why we are building the database. Now, let us look at the various, it turns out that there are various types of these attributes, and that will give us an idea of the modeling capabilities that we have in this model. Simple attributes. Simple attributes are those attributes that have atomic or indivisible values. Atomic or indivisible values. That means, for our purpose we will treat those values as indivisible values. Like a phone number is a 10-digit number. Okay. Department is a string. So, department attribute used for describing some entity is a string. The phone number attribute is a 10-digit number and we will treat that as an atomic number. So, some phone numbers do have area codes and then other things, but then for our purposes we will treat it as atomic thing. Okay. So, the important thing is that if we model it as a simple attribute, we are agreeing that we will treat it as a atomic indivisible value. Indivisible value. For example, a building name or a room, for example, my room is BSB 309. Okay. You may say that okay, the BSB actually stands for building census block and your room number is 309. Okay. Should we split it like that? It is again a design choice. We will if we model it as a simple attribute, then we choose not to split it, we use it as it is. Okay. So, that is the spirit behind simple attributes. Whereas, we have composite attributes. These composite attributes have several components in the value, several components in that particular value. Like for example, if you take qualification as an attribute of an individual person, then it is natural that it has components like degree name, name, what is the name of the degree, and year, the year of granting of that particular degree, and the university name, what is the university that granted that particular degree to that particular person. So, these are the various components that we can imagine to be present in the qualification attribute. So, these kind of attributes are called composite attributes. So, we have simple attributes as well as composite attributes, and depending on when we discuss with the end users as to how they would like to see their information to be captured, we will use them appropriately. We will ask them, is this is a simple attribute enough for this particular capturing of the attribute, or is the composite attribute required? What is the kind of information that you want to capture, and then make a choice. Now, there are also what are called derived attributes, attributes whose value is dependent on some other attributes. The classic example here is the age. The age depends on date of birth. So, date of birth is an attribute and age is another attribute, and it is called a derived attribute, because you do not have to specify the value for this age if you have already specified what is date of birth. It can always be calculated and derived. So, we have the notion of derived attributes as well. Like the interest amount on a deposit is a derived attribute, because it depends on the rate of interest. Now, moving on, another kind of classification for attributes is this attribute a single valued attribute? Is it just one value, or is it going to be a collection of values? For example, okay, so single valued means the attribute has exactly one value rather than a set of values. For instance, the place of birth is a single valued thing. You cannot have two places of birth, right. So, by its very nature, the place of birth attribute exactly has one value. So, it is a string value, and whereas there are some attributes which are naturally multivalued. That means, they have a set of values associated with them, but not a single value. For example, the email address attribute of a person is typically having multiple values, because you have a institutional email, you have personal email address, and maybe some other email address and things like that. You have multiple email addresses. The previous degree attribute for a student typically has more values. A student might have multiple degrees earned before he is enrolled into one particular degree. The courses enrolled attribute for a student is typically multivalued, because each student typically enrolls for multiple courses in a particular semester. So, like that, these are certain attributes are multivalued, and whereas certain attributes are single valued. So, now we have seen two kinds of ways of looking at attributes. One of them is, are they simple or composite? Okay. Simple means it has only one component, it does not have multiple components. Composite means it has components inside it, whereas single valued means it always has a one value associated with it, whereas a multi-valued means it has a set of values associated with it. Now, all these four things, I mean the two of the simple composite and single multi-valued can actually combine, and then we can have four possible combinations of these things. So, attributes can be simple single valued or simple multi-valued, composite single valued or composite multi-valued. For example, the previous degree attribute of a student is actually multi-valued and is also composite. It is also composite because each degree has components in it. what is the name of the degree, what is the year in which it was granted, who granted that degree, it is naturally multivalued. So, it is a composite multivalued attribute. Okay. So, are there any questions now? So, here is the diagrammatic notation for entities, diagrammatic notation for entities that is typically made use of in this context. So, let me tell you, describe to you this. So, we write the name of the entity in like this, student. We typically do not write students, okay. We do not write the plural of the verb there, sorry, noun. So, usually write just the singular name, student. So, that is the name of the entity, and entity is always described using a rectangular box, and then around that we have lines connecting the connecting to the entity, and then we write attributes in ellipses like this. So, the program is an attribute. So, it is supposed to have a value depending on what is the program the student is enrolled in, like is he a BTech student, an MTech student, a MS student, a PhD student and all that. And then we have roll number as an additional attribute, and then here is a student name attribute. This one is a composite attribute. So, if it is a composite attribute, then it will be an ellipse and it will have other ellipses connected to it. So, this particular attribute has the last name, first name, last name and multiple middle names, So, multiple middle names. So, if this is a multivalued, then we put double ellipse to indicate that it is multivalued. So, this is a very this kind of a modeling is appropriate for our names, because most people have a first name and a last name and multiple middle names. Typically, Indian names do have several middle names, okay. Especially people from Andhra Pradesh have long names, right, and so it is natural to capture them using multiple middle names. Okay. Then we have this simple email address, but it is multivalued. So, it is simple multivalued. Here is composite attribute, one of its components is multivalued, okay, and here is date of birth, which is a simple attribute. And sometimes we underline a particular attribute. I will tell you why we do that in the next slide. Sex is another attribute, age is a derived attribute, it is derived from date of birth. So, like this we have this diagrammatic notation to describe the entity and its. So, typically the situation that we are modeling for which and the situation for which we are building the information system has several entities of this kind, and we engage with the stakeholders in a discussion and then elicit, collect all this information from them and then develop these diagrams and then have a discussion with them to kind of finalize our understanding of the domain for which we are building the information system. Now, remember that this is all data model requirements. This is not functional requirements. Functional requirements are separate, right? Functional requirements are not captured in this particular model. Now, what exactly are these mathematically? So, mathematically each of these attributes has a domain associated with it. Domain also are sometimes called value sets, value set. So, each attribute takes values from a set which is called its domain. For example, the student age, we can say that it has values, this is the set of values associated with. We do not expect students to have age more than 55, and I think the entry age is 17 here, right, for example. And then we say that home address is a character string of length 35. We fix it saying that 35 characters is probably enough to take care of the home address. So, like that we have domains. Domains are basically nothing but sets of values, and these are associated with these attributes. Now, for composite attributes, we can think of that as having a value which is a element of this cross product of the domains of the component attributes, right. So, for a composite attribute, the value is a tuple actually, right. It is a composite attribute, it has components. So, naturally we can think of the value as a tuple, and tuples are, so these tuples come from the cross product of the domains of the corresponding component attributes. There are components inside the composite attributes. So, for those component attributes we have domain sets. So, we can take those domain sets, form the cross product, and consider the member of the cross product as the value of this composite attribute. In a similar way, for multivalued attributes, we basically take the sets of subsets, the set of subsets, the power set of the values from the basic domain as the domain, because it can have multiple values. Like for example, courses registered is a multivalued attribute. So, we will take the basic domain, which is the course thing, and then consider subsets of courses as the values for this multivalued attributes. Okay. So, we have these domains. Now, moving on, there is an interesting aspect about certain kind of attributes, and they are called key attributes. Okay. So, for an entity set, we designate an attribute or a collection of attributes. Okay, is it either a single attribute or a collection of attributes together that have this interesting property that their values would be able to uniquely identify an entity in the entity set. Such attribute is called a key attribute. Okay. So, let me repeat, a key attribute or key is basically either a single attribute or a collection of attributes whose values can be used to uniquely identify one entity in the entire entity set. So, entity set has lots of entities. So, how do you identify one of them? How do you pick one of them if necessary? What we are saying here is that there are certain attributes whose values can help us to uniquely pinpoint one attribute, one entity in this entity set. So, let me give you an examples. The roll number. The roll number is a key for the student entity set. The moment you give me a roll number, I will be able to identify what student you are talking about, who are you talking about. The employee ID is the key for the faculty entity set. Okay. For the same student entity set, let us assume that each student gets to stay in a single room, in a single room, assigned a single room, and these rooms are there in hostels, and so the name of the hostel and the room number together would be a key under this assumption that each student gets to stay in a single room. Okay. So, So, we are kind of the situation that we are assuming here is that students all students stay in hostels, first thing, all students stay in hostel, and there are multiple hostels, each hostel is identified by a name, and then there is a room number, and these hostel name together with the room number will serve as the key for the student. We can uniquely identify the student because of this assumption, right. Now, so as I was mentioning here, a key for an entity set may have more than one attribute. For example, here hostel name, room number are two attributes, and also an entity set may have more than one key. An entity set may have more than one key. For example, the student entity set here has roll number as one key, and then the hostel name, room number together as a key. For example, for a faculty member who is an employee, employee ID is a key, and there are certain global attributes like for example, the PAN number, the permanent account number of for taxpayers that is given. We all have a PAN number. So, you can uniquely identify the ID number faculty by his PAN number also. The institute actually also gives brief abbreviated names for faculty, so that they can be identified uniquely using that abbreviated name. Okay. So, you can see that basically the point I am trying to convey here is that entity set may have more than one key, and a key can have more than one attribute also. Now, who determines these keys? That is an interesting question. Keys can only be determined from the meaning of these attributes of those entity types, okay, and under the underlying assumptions in the domain. So, they have to be kind of determined by the designers at this stage. When we are designing the model, we have to identify. So, you cannot take a set of entities and then just look at them and then and the values and things like that, and then simply decide that something is a key. Okay. It has to come from the underlying meaning of the attribute. That is the important thing. For example, if you write down a bunch of names and other details of student entities, some 100 student entities on a sheet of paper, and then I can go through and then I figure out that okay, the first name seems to be a key, because it so happened there are no two Srinivasas in that particular set, but that doesn't really make first name as a key, because we know that there are people who have certain first names that are very common, and so a first name cannot be a key at all for a bunch of people. So, it kind of comes from the natural meaning of this attribute. So, it has to be designed by the attribute. We cannot examine a collection of entities and then come to some conclusion based on that particular data set. Okay. So, let us summarize. So, we have this concept of entities. This is the entity relationship. So, the first thing is entity, and we have this notion of entities and entity types, and then attributes for them and various kinds of attributes. So, these are all collection of conceptual tools that are available for us to start modeling the domain. Moving on, let us look at relationships now. Okay. Now, relationships is the other major concept that is available in the ER model. Basically, what it allows us to do is to capture associations between entities. So, entities do not simply exist in a domain, they also interact. I mean, there is some associations between them. So, we want to capture them. When two or more entities are associated with each other, we have an instance of a relationship. Okay. Let me give you an example. For example, the student Ramesh enrolls in discrete mathematics course, typical scenario. So, so the entity types here are in italics. So, student is an entity type, Ramesh is okay, let us assume that we are talking about one particular individual, and discrete mathematics is a course, and enrolls is this association between these two entities. So, this is a this is a potential name of a relationship, that enrollment or enrolls. So, this particular thing in fact is one instance of that relationship. There are several instances of that kind of relationship, that there are several people who are enrolling into different kinds of courses. So, each of them is an instance of this enrolls relationship. So, the relationship enrolls basically has the student and course as the participating entity sets. Participating, we call it as a participating entity sets. Now, formally speaking, enrolls can be thought of as a subset of the cross product of the student and course entity types. The student entity, course entity. So, each of them is a entity type. So, it has a collection of entities in this student, a collection of course. So, who is doing what course? So, if some S C belongs to enrolls, what it means is that student S has enrolled in course C. Okay. So, basically tuples in this enrolls are these relationship instances, and enrolls itself is called a relationship type or set. Just like we had entity type, we now also have a relationship type, okay, which captures basically a bunch of associations of the same kind are put together in a relationship type. So, enrolls is a relationship type, and there are several instances of this relationship, each of them having two components, which is this student course in this case. Now, we use the term called degree for a relationship, basically to capture as to how many number of entities are participating in that relationship. So, typically it is binary, but in some situations we may have to use ternary and sometimes n-ary relationships. Okay. So, degree 3 means 3 entities are participating in that relationship. So, the tuples will be having 3 components. Degree n is n-ary. So, in general you can see that. So, basically the idea the term degree is used to indicate the number of participating entities in the relationship. So, here is the diagrammatic notation for relationships. Relationships are shown using a diamond, and all the participating entities, which are rectangles, right, are connected to the relationship symbol. and we write the name of the relationship here and the name of the. So, remember that this has other details to it, like for example, all the attributes are around this, right. So, there is a lot I have not shown those things, but those things are there. Now, so similarly this also has attributes around it, and now there is a new thing we are bringing in, the relationship, and so the relationship we draw in a diamond shaped box and then draw lines to indicate that all these three entities are participating in that relationship. Okay. Now, probably I will stop here for today because it is 8:45. We will continue in the next lecture with various kinds of relationships that are existing and how we can capture details of the domain using those relationship kinds. Okay.